So here's the second day of 3.7, graphing systems of linear inequalities. So number 20, first thing I'm going to do is isolate my y value by subtracting x. So my first equation ends up y greater than negative x, gives me a slope of -1, a y-intercept of 0. Second equation, I subtract 2, noticing that I only have a y value, so this is going to be a horizontal line. So I graph my first equation in black and shade above, graph my second equation in pink, shade above, and their shaded region they share is above the horizontal line and above the dotted line with a slope of -1. Number 21, very similar work. I'm going to isolate y by subtracting x, gets me a slope of -1 with a y-intercept of 0. Second equation, I'm going to subtract x, then divide by -1, which results in flipping my sign. I graph my first equation in black and shade above. My second equation, I graph in pink and shade above. The shaded regions that overlap are this upper kind of triangle starting at 0, 0. 22, you're going to see in a lot of these, we're doing a lot of the same work. 22, I begin by subtracting x in each equation. First equation, I have to divide by -1, results in flipping my sign. Graph my first equation in black as a solid line that is shaded above. My second equation in pink that is a dotted line shaded below. And the region that overlaps is this triangle-like shape on the left. 23, don't have to do anything to my first equation, so I can go ahead and graph that in black. Second equation, I subtract 1, divide by -1, which results in flipping my sign. And again, I see that I only have a y value, so I know I have a horizontal line at 1. Graph my first line with a y-intercept of 2, slope of 1, shade below it. Second equation is a horizontal line at 1, shaded above. And so the shaded region they share is this upper to the right triangle-like shape. 24, first equation I subtract 2, gets my y isolated, so I know my slope is -1 and my y-intercept is 2. Second equation, I start by adding x, so I get a slope of 1 and a y-intercept of 2, so they share a y-intercept. Graph my first equation in black and shade below, second equation in pink, shade below, and so the region where it overlaps is this bottom triangle. 25, first equation, I start by subtracting x. I have to divide by -1, so note that it requires me to flip the sign. Second equation, all I have to do is add x. So I end up with two lines that have the same slope, different y-intercepts. So they're going to be parallel. I shade my first equation in black. Graph my first equation in black and shade above. Second equation in pink and shade below. So the area that overlaps is this region between the parallel lines. 26, start by subtracting x in my first equation, start by subtracting x in my second equation. Again, I end up with two lines that have the same slope. When I graph my equation in black, dotted line shaded above, graph my second equation in pink, dotted line shaded below, and again, I end up with my shaded region, the area in between my two parallel lines. And finally, 27, start by subtracting x in each equation, divide by 2 in my first equation, so I get a slope of -1/2 and a y-intercept of 1. In my second equation, I have to divide by -2, so notice I flip my sign. Graph my first equation in black, it's a dotted line shaded beneath. My second equation in pink, it's a dotted line shaded above. And so that the area where they overlap, sorry, it looks like I didn't show where they overlap. So the solid line below, so the area that they overlap is just this triangle down at the bottom. All right, hope this helps. If you have any questions, feel free to ask in class.